Okay, so we will be starting from question number 13. Compound Z is insoluble in water, but soluble at low pH. It indicates that, for example, at pH 7, the compound is insoluble, but at pH lower than 7, it is soluble. Okay. Which compound, what could be the compound Z? Okay. So here we have all the compounds of barium. So barium can react with acid. Barium carbonate can react with acid, but barium chloride doesn't react with acid. And barium chloride is also soluble in water at pH 7. So B goes wrong. When we talk about barium hydroxide, also reacts with acid. When we talk about barium sulfate is insoluble in water and it also doesn't react with acid as well. Okay, so B and D are completely wrong. Now we have to choose between barium carbonate and barium hydroxide. The thing is that if you recall, down the group 2, hydroxide solubility increases, right? If you remember this trend. So it indicates that barium hydroxide is soluble in water as well. So soluble in water, then it is also a wrong answer. It means A is the correct answer because when we talk about barium carbonate, it is insoluble in water. But readily reacts with acid and dissolves. Is this understandable to everyone? Yes. So our correct answer is A. Okay. Now, question number 14. Just give me a minute, please. Okay. Hot aqueous sodium hydroxide reacts with chlorine. Okay, and here they have given you the equation. Which statement is correct? Okay. The oxidation number of chlorine and hydrogen both changes in the reaction. Okay, so let's have a put the oxidation number of chlorine and hydrogen. If you see, hydrogen is +1 over here, and here hydrogen is still +1. Okay, so in both the cases, the hydrogen atom is +1. So this for hydrogen is wrong. So A option is incorrect. Okay. Now let's have a look at the oxidation numbers of chlorine. Oxidation is sodium +1 oxidation number. So chlorine must have a minus. Here, chlorine is with sodium and oxygen both. If you work out the oxidation number must be -6. It means both the sodium and chlorine have a +6 oxidation number because the net charge is 0 and sodium is in group 1, so it have a +1 oxidation number, which clearly indicates that chlorine have a +5 oxidation number. So for chlorine, this statement is correct, but for hydrogen, this statement is wrong. Is this understandable to everyone? Now, part B, option B, the oxidation number of chlorine in the products are -1 and +1. No, we have figured it out that -1, one chlorine is -1 and the other chlorine is +5. So B option is also wrong. Now, C, if aqueous sodium hydroxide is cold, the reaction produces NaClO instead of NaClO3. So if you look at this statement, this is correct, but we have to further assure that whether our D statement is correct or wrong. So sodium undergoes disproportionation reaction in this reaction. So if you work on the oxidation number of sodium, so sodium have a +1 oxidation number on the product and on the reactant side. So it is the wrong option, because if you recall, disproportionation means that a substance or a species both and oxidation. So that's why D option is wrong and our correct option is C. Is this understandable to everyone? Now, question number 15. Is put into a test tube and solution X is added. Okay. The resulting mixture is warmed and the gas given off is tested with damp red litmus paper. The litmus paper changes from red to blue. And what could be the identity of X and its role in the reaction? So if we have solid ammonium nitrate, and we have a compound X, a solution X, and what they are telling us that on warming or on heating, there is a ammonia gas. And how we could know that the ammonia gas is formed? Because the red litmus turning into blue. So what could be the identity of X? So if you recall, any ammonium compound can give off ammonia with alkali only. So it means that it alkali C or D are wrong. It can be alkali, and alkali is a proton acceptor, not a donor, right? So A goes wrong and B is our correct answer. Is this clear to everyone? Now question number 16. Sodium, magnesium, and aluminium are three elements in period 3 of the periodic table. Each element form an oxide. Okay, so sodium forms sodium oxide Na2O, magnesium forms magnesium oxide MgO, and aluminium forms aluminium oxide is Al2O3. Okay, so if you recall, sodium oxide is basic, magnesium oxide is also basic, and aluminium oxide is amphoteric, right? And the other thing about these three, these all are ionic compounds, so they all have a giant ionic lattices and high melting points. So sodium oxide is basic, magnesium oxide is amphoteric, so A goes wrong. And so it's because it's also ionic. The option is wrong. High melting point. Aluminium oxide is also a giant ionic, so it must have a high melting point. And aluminium oxide is also a giant ionic, so it also have a high melting point. So this option, C option, also goes wrong. So it means our correct answer is D. So if you look at the information provided over here, sodium oxide reacts with water, correct. And if we talk about magnesium oxide, it reacts slowly with water, yes. And no reaction with water because of a oxide layer, or because aluminum oxide actually doesn't dissolve in water. It is insoluble in water and it doesn't react with water. Okay, now question number 17. A student investigates calcium nitrate crystals by heating them in the apparatus shown. A colorless gas leaves the apparatus at Y. A flame is held to this gas. Okay, so it's a calcium nitrate. So if you recall the decomposition equation of calcium nitrate, so on decomposition, it forms calcium oxide solid, nitrogen dioxide gas, which is of brown color, and oxygen gas, which is colorless. Okay, it is brown color gas. Okay, what observations would the student make? So can anybody figure out the nature of the NO2 gas? If you oxygen is neither acidic nor basic, but if we talk about NO2, it's a non-metal oxide, so it must be acidic. And if it is acidic, just give me a minute, please, everyone. Okay. Yes, am I audible to everyone? Okay, so it's an acidic gas. And if it's an acidic gas, then the litmus changes to red. And if the litmus changes to red, then A and B both are wrong. And if we talk about the flame test, then oxygen, normally what is the test for oxygen? It rekindles the glowing splint. So if there is a flame over there, so in the presence of oxygen, what would happen? That flame burns more brightly. So this statement is correct and this is wrong. So D goes wrong and C is our correct answer. Is this understandable to everyone? Okay. Now, question number 18. How does concentrated sulfuric acid behave when it reacts with sodium chloride? So if you recall this reaction, that when sodium chloride and sulfuric acid would react, you will either get sodium hydrogen sulfate and water, or if there is excess of sodium chloride with sulfuric acid, so you would get sodium sulfate, sorry, not water, HCl, and HCl in both the cases. So if you look at the behavior of sulfuric acid in both the cases, that sulfuric acid is actually donating the hydrogen ion. It's a H positive ion donor. So it means it is behaving as an acid only, which means A option is correct and our rest of the options are wrong. But if you recall, when there is a, instead of sodium chloride, if there is a sodium bromide or sodium iodide, when the HBr or HI is formed, it further reacts with sulfuric acid, and where sulfuric acid is actually behaving as a oxidizing agent. But with chloride, it doesn't behave as an oxidizing agent, it just behaves as an acid only. So you have to remember this. Now, question number 19. Which statement about nitrogen or its compounds is correct? Okay. In the Haber process, the temperature is kept high to give a good equilibrium yield of ammonia. Is this statement is correct or wrong? If you recall, we do keep the temperature high, but not for the good equilibrium yield, because the exothermic, but when we lower the temperature, obviously we are the equilibrium will shift towards the right, we will get the more product, but the rate gets slower. So in this case, we are keeping the temperature high to actually maintain the rate of the reaction, to speed up the reaction, not, to increase the yield. Okay. So A option is wrong. Now, next option. Nitrogen gas is unreactive because of the strong nitrogen-nitrogen double bond. Yes, it can be correct, but we have to further figure out the rest of the options first. Nitrogen monoxide, NO, react with carbon monoxide under suitable conditions. Yes, I think that this is completely correct, because this happens in catalytic converter in car exhaust, where nitrogen oxide reacts with carbon monoxide on catalytic converter, forming nitrogen gas and carbon dioxide. So this is correct as well. The formula of ammonium sulfate is NH4SO4. No, it is completely wrong. It's correct formula. If you recall, ammonium sulfate have 2 ammonium ions and 1 sulfate ion. So D goes wrong. Now we have to opt between B and C. If we consider if we consider nitrogen as, unreactive, then how could it take part in Haber process? If it is doing the reaction in Haber process, further nitrogen also reacts with other substances. Yes, it do have a strong nitrogen. Okay, one more thing, sorry, I overlooked. It's a double bond. Nitrogen have a triple bond, so it is wrong. There is no other comment about it. Okay, so the C option is correct. Now question number 20. Which pair of compounds are functional group of isomers of each other? Okay. Now, in the previous pattern, where you have a section A and section B in the MCQ paper, you are going to find the last 20 or last 10 or 11 questions from the 20 or 21st till 30, all from organic, okay? All these questions are from organic. Which pair of compounds are functional group of isomers of each other? So it's easy. If I recall, if you remember, an alkene and cycloalkane, I have made a list in the lectures, are the functional group isomer of each other. Aldehyde and ketone are the functional group isomers of each other if they have a same number of carbon atoms. Carboxylic acid and esters are the functional group isomers of each other in the same way. Alcohol and ether are the functional group isomers of each other. If you recall, there is one more thing. Alcohol and carbon-carbon double bond, OH and carbon-carbon double bond, if these two groups are present in one compound, so it can be a functional group isomer of aldehyde and ketone. So here we have an alcohol and an aldehyde, so A is not the answer. Here I have a 5 carbons. If you work on this, there are 2 carbons over here and 3 carbon over here, and it's an ester. And here we have an acid. So this is the correct answer. Hexene and hex2ene, they two are isomer of each other. But the thing is that they are position isomer, not the functional group isomer, because both have a double bond, carbon-carbon double bond. Okay. Propylamine and propane nitrile. So propylamine is basically CH3, CH2, CH2, NH2. And propane nitrile is CH3, CH2, CN. So if you see, it is C3. How many hydrogens it have? 9 hydrogen and nitrogen. If you look over here, C3, 5 hydrogens and 1 nitrogen. So these are not the isomers at all. So our correct answer is B over here. Is this understandable to everyone? If anyone have any doubt, do ask. Okay. Now, question number 21. Which row identifies a suitable starting material and reagent that can be used to produce butane nitrile? So, butane nitrile is C4. And if I will go for the structural formula, CH3, CH2, CH2, 3 carbons, and the 4th carbon is triply bonded with nitrogen. So it is this one. Okay. So in the first case, we have a propane nitrile and the reagent is HCN. So if you recall, with an alkyl halide, the reagent we can use, it's wrong. We can either use NaCN or we can use KCN in ethanol. So A option is wrong. Here, okay, if you look at these two are completely wrong. Why? Because they already have a 4 carbons, and if we substitute a CN instead of butane nitrile, we will get pentane nitrile. So these two are going to give you pentane nitrile, 5 carbon atoms containing compound, and we need a 4 carbon atoms containing compound. So that's why it's clearly wrong. So we are left with only B option. So our B option is correct, because when NaCN in ethanol reacts with the bromopropane, the cyanide ion substitutes the bromide from the bromopropane, forming butane nitrile. Is this clear to everyone? In this reaction, this would happen, that CH3, CH2, CH2, CN, and sodium bromide. I hope is this clear to everyone? Okay. Now, question number 22. The diagram shows the structure of the ethane dioic acid. Okay, it's a carboxylic acid and two carboxylic acids group on both the carbon atoms. Ethane dioic acid reacts with ethanol in the presence of a few drops of concentrated sulfuric acid to form diester. Okay, there are two carboxylic acids group, so both can releases their OH to form an ester. The molecular formula of diester is C6H10O4. What is the structural formula of diester? So see what we are adding, ethanol. So if you recall ethanol, it is C2H5OH, right? So what would happen? OH from here is removed and H from here is removed. So what would happen? This carbon is going to bond with the O of an alcohol. Then we have a CH2, then we have a CH3. In the same way, this is also removed. Here we get an O of an alcohol, which is bonded to CH2 and which is further bonded to CH3. So that is the structure. So on the basis of this, if I will write the structural formula over here, so it would be CH3, CH2, then there is a O over here, so I can write O2C, CO2, CH2, CH3, or instead I can write CH3, CH2, then there is a O, then CO, then next carbon have a two carbon, CO2, then CH2, then CH3. So here the CO2 is written first, which means A is wrong. Now, if you look, this resembles this one. So this one can be correct. If you look over here, O2C, then again O2C, which is wrong because there is a first C and then oxygens. So from this place, it is wrong. So C also goes wrong. And here, it is completely wrong. So our correct option is B. If anyone have any doubt, do ask. Now question number 23. Okay, it's from infrared. Okay. The infrared spectrum shown was obtained from a compound J. So what I can clearly indicate from this that there is no OH or COOH, right? Because we have a very, observable peak for these two. Which statement about compound J is correct? Okay. So can anybody look in the spectrum and tell me that CO is there? Yeah. So CO is there. And they are asking about C triple bond N. Okay. So C triple bond could be observed at 2200 to 2250. So here is 2200, 23, 24, so 2350. So we are not observing any peak over here. So it means C triple bond is not there. So A goes wrong. B is wrong because it is saying that CO is not there. C triple bond is not there. That's fine. So C says C double bond O is present, but not C triple bond N. Yes, this is correct. And again, D option is wrong. So here in this case, our correct answer is C. Is this clear to everyone? Yes. Now question number 24. A section of a polymer chain is shown. What is the correct monomer? Okay. So if we start from here, then this is your monomer. Why? Because if I use the different colors, then you can clearly observe the repeat unit over here. See? So it means if I draw over here one repeat unit, then and here I have to put the double bond. So the double bond, if you see from one side, is on the second carbon, right? And the branch is on third carbon. So, and then there is a branch on fourth carbon as well. A third carbon have a branch have containing two carbons, and the fourth carbon have a branch of one carbon. So if you see over here, if I start from here, 1, 2, 3, 4, and 5th. See, aren't they both resemble with each other? That the second carbon have a double bond, the third carbon have a branch of two carbons, and then there is a fourth carbon have a one branch, and there is a fifth carbon. If I start from here, 1, 2, 3. So see here, the second carbon doesn't have a double bond as well as a branch, so it goes wrong. If I start from here, so in this case, in either case, from where I would start, the double bond is coming on the third carbon, so that its position is completely wrong. So that's why it is also considered as wrong. Now, if you look at the D, 1, 2, the second carbon have a branch and double bond both. So D goes wrong as well. It means our correct answer is A. A is clearly, resembling the uh, monomer unit that I have drawn. Is this clear to everyone? Question number 25. Structural isomers and stereoisomers should be considered. Yes, Fariza, what is the problem in this question? Do ask. Where you get confused actually. Is this part is clearly understandable? Yeah, it is why if you compare it with the monomer that I have drawn, in that monomer, see, this is carbon 1 and this is carbon 2. There is no branch on carbon 2. But if I start from here, this is carbon 1 and this is carbon 2. The carbon 2 have a double bond as well as a branch. But if you see, the carbon 2 have a double bond, but there is no branch in the monomer. So that's why I marked B wrong, because according to the monomer that I have drawn, I can clearly say that carbon number 2 must not have a branch. Is this understandable? So that's why I marked B option wrong. And in the same way, that's why I marked D option wrong as well, because on the second carbon, there is a branch as well. See, there is a double bond and there is a branch which is further splitting into a branch. If you have still confusion, do ask, or otherwise I will proceed further. Okay. Now, question number 25. The structural isomerism and the stereoisomerism should be considered when answering this question. How many non-cyclic isomers have the molecular formula C5H10? Okay, so if you look at C5H10, its general formula would be CnH2n, and they have said that non-cyclic, which means that all must be alkene. So it's easier if you work on, the skeletal formula. So there are 5 carbon atoms, 1, 2, 3, 4, 5. I'm going to put a double bond on the first carbon. It is not going to show you any cis trans isomer, okay? Now, so that is your one isomer. If I keep the 5 carbon atoms in a row and shift the position of the double bond over here, then this can show you cis and trans both. So here we got second isomer and the third isomer. Is this understandable to everyone? Yes. Now, if I further switch the position of the double bond, it still remains on carbon number 2. So that doesn't make any sense. So we got 3 isomers. Now what I can do, instead of making the 5 isomers in the row, I can make the 4 isomers in the row and a double bond over here. Okay. And a branch over here. So that can be my 4th isomer. Is this clear to everyone over here? Now, what I can do next, I shift the double bond and put a branch where it was earlier. So I get the 5th isomer. So 4th and 5th both doesn't show cis and trans because one of the double bonded carbon have a same groups. Now, what can be any other possibility? I again make the 4 carbon atoms, double bond on one side and branch on the other side. That can be my 6th isomer. And it also doesn't going to show you any cis and trans because one double bonded carbon have a, same groups. So in total, I am getting 6 isomers. Out of these 6, 5 are position and chain isomer. And total there are 6 position and chain isomers, and out of those, one is actually showing cis and trans. So in total, we are getting 6 structural and stereoisomers for this one. Now, question number 26. Okay. An excess of a dry HBr is formed with compound Y. Okay. HBr and excess. So, if you recall this reaction, HBr reacts with an alkene and HBr also reacts with an alcohol as well. So what would happen that here OH is substituted by Br and the double bond have a one bromine and a hydrogen over here, and that double bond also have a one bromine and hydrogen on the other side. So there is no need to put the hydrogen in the skeletal form. So A goes wrong. Why? Because of a double bond. B goes wrong because there is a still OH over here. C further, this is the major product. I have drawn the way in which we get the major product. So here they put the Br on the wrong place because this product can also be found, but which is a minor one, not the major one, according to the carbocation stability that we have discussed. So our correct answer is C. Is this clear to everyone? Now, question number 27. Which reaction would produce propanoic acid as one of its products? Okay. So in this case, it's an alkene and we are heating with concentrated acidified KMnO4. So if you recall, this would be going to break down from here. The part or the fragment of the molecule on the left would turn into ketone and the one on the right would turn into propanoic acid. So this would be a correct answer. But let's have a look over here. Heating an ester with the NaOH. So this ester would going to be break. And due to the presence of NaOH, instead of propanoic acid, we are going to get its salt and propanol. So B goes wrong. Heating ethanol with acidified dichromate. So it would give you ethanoic acid, not propanoic acid. So C goes wrong. Reacting an aldehyde with HCN, it would give you, and heating the product would, okay, it would give you hydroxynitrile first, OH, H, and C triple bond N. And when adding a sulfuric acid, as they have said, that nitrile turns into carboxylic acid, but it is still not forming propanoic acid. Instead, it is forming hydroxypropanoic acid. So D goes wrong as well. In only A, we are getting the propanoic acid. Is this clear to everyone? Okay. Now, question number 28. Compound X is treated with an excess of lithium aluminum hydride, LiAlH4, and it's a reducing agent. The reaction is allowed to go to completion. Okay. What is the structure of the organic product? So if you recall, there is a ketone. So what would happen? It turns into an alcohol. Then there is a carboxylic acid. It also turns into an alcohol. So on the basis of this, due to this and this, A goes wrong. Due to this, B goes wrong. C goes wrong due to this. And D is our correct answer because both are turning into an alcohol. Is this clear? Yes. Now, question number 29. What is the skeletal formula of compound formed when this is heated under reflux with K2Cr2O7? Remember, K2Cr2O7 reacts with alcohol but not with aldehyde. So what would happen? That it stays CH3, CH double bond CH and CO2H. So if I turn it into an skeletal one, so 2, 3, 4 carbons. Fourth carbon have a carboxylic acid. That can be a first carbon and there is a double bond. So it means A is wrong, C is wrong, D is wrong, and B is the correct answer. Is this clear to everyone? Yes? Okay. Now question number 30. The diagram shows the structure of a compound Q. Two of the rings X and Y contain carbon-carbon double bond. Which row is correct? Number of ester groups in one molecule of Q. So if you see in one molecule of Q, there is one ester group over here, and there is another ester group over here, which means there are two ester groups. So A and B goes wrong, and we are left with C and D. Description of the rings X and Y. So if you look over here, this carbon, this carbon, this carbon, and this carbon, all of these carbon are sp3 hybridized, which means between these carbon atom, the bond angle is 109.5 degrees, right? In the same manner, if you look at these carbons, so these carbons also have a sp3 and bond angle is 109.5 degrees. So if the bond angle is 109.5 degrees, so they can't be planar. So C is wrong. These two are wrong due to this figure and this figure. No, this figure and this figure. So our correct answer is D. Is this clear to everyone? Okay, so now in the next class, we will be going to start a new paper. I'm not going to discuss section B because this is not the part of your paper now. You have the questions like these only. So tomorrow, inshallah, we will have a next class and we will start with the new paper. Okay. Okay. Take care, everyone. Allah Hafiz.